How to build a Blackgates Sweep P 5-inch gauge locomotive, part 21. After the boiler had been in my acid bath for 24 hours, it was time to give it a thorough wash inside and out, and have a closer look at the slight leak in the firebox. I also bought some more steel from Blackgates Engineering to improve the quality of the existing platework. The boiler is sat on a picnic bench outside my workshop, and I have a hose pipe, and I've been cleaning it using that. First of all, the inside, very important to get rid of any acid from inside the boiler, followed by the outside. As you look at this boiler in this position, the slight leak is a crack in the silver solder at the side of the superheater tube. I'll use an arrow to indicate just exactly where it is. Here I'm continuing the washing process because it really is important to remove every trace of the acid. I use Kilrock K kettle descaler, which is formic acid, and it's not very strong, but nevertheless I do need to remove every trace of the acid now that it's out of the acid bath. I also cleaned up the area around the superheater tubes and one of the other tubes using a small rotary wire brush, so there is no doubt where the leak is. The silver soldering is generally good on this boiler, so I'm not worried about the quality of manufacture at all. But the internal leak in the firebox is in the worst possible place. I cannot use my standard propane blowtorch. Unless I can find someone in the York area who can help me out with this boiler, what I'm going to have to do is buy an oxypropane set. And by using a standard propane torch on the outside of the boiler in the area of the leak, and oxypropane or oxyacetylene on the inside, I should be able to fix it. I am fighting the urge to use Radweld or a similar compound because this leak is really minor. That's enough of that. I'm back inside the workshop, and here I've bought some more steel plates to replace the existing ones that were on the engine. Matt at Blackgates Engineering cut the parts to exactly the right shape that I needed them to be. Sadly, I no longer have a metal cutting guillotine big enough to do this job. Having the parts pre-cut to size does save a lot of time. Whilst I was at Blackgates Engineering, I also bought some other bits and pieces, one of them being this very old pair of tin snips, just like the ones my father used to have. I already have a modern pair of tin snips, but to be honest, I think they're really cheap and nasty and I don't like them. In this clip I'm using the modern pair of tin snips. After making some adjustments to the blades of the old pair of tin snips, they cut this very thin piece of brass absolutely beautifully, with very little distortion. While I was at Blackgates Engineering, I also bought some steel bar. Here's one of the pieces. I'm just wiping the oil off it. I intend to use the steel bar instead of using angle. It is heavier, which is good for traction weight, but the best reason for using it is that you don't need to mess about with nuts and bolts. You can thread the steel bar itself and just screw the bolts straight into it. And this in turn speeds up the job. The bolts in the original plates were countersunk machine screws, which quite frankly look ridiculous. It's one of the first things you see when you look at the front of the locomotive, so when I come to make the new parts I'm going to use hexagon-headed bolts instead, which I think will look a lot better. And thinking about it, I will probably use more than 3 at the front. I'm removing every one of the slot-headed countersunk screws, and temporarily I'm putting these machine screws in the box of fixings that I have. Most of these bolts came off the engine when I dismantled it, but I think when I fit the new parts to the chassis I will use new fixings. This clip shows that the new pieces of steel that Matt cut for me on the guillotine at Blackgates Engineering are thicker than the originals. This makes the parts more robust and overall slightly heavier and much stronger. Here is a serious, common sense health and safety warning. Before working on bits of metal that have been cut using a guillotine, remove the sharp edges. Becoming lacerated and bleeding in the workshop is not recommended. In this clip I'm in the outer part of the workshop removing the sharp edges. In reality, the edges are only sharp at one side. But the sharpness of the edges does vary depending on how the metal was held in the guillotine. And here is a top tip. Do not run your finger down the edge of the metal to find out which is the sharp part. Once upon a time, many years ago, I cut myself really badly working with a stainless steel sink unit. I was trying to fit it into a worktop and it was a bit wet and slipped through my fingers. and I received a long straight cut which bled profusely for quite a while. And ever since that day, whenever I work on pieces of metal that are sharp, I remove the sharp edges before working on them. There are 3 pieces of steel, one for each side at the rear which supports the cab, and then there's a fancy shaped piece for the front. Recently, in a series, I was working on a 7 1/4 inch gauge Sweet William, which is only really a larger model of a Sweet Pea. On the Sweet William, I had to reinforce these parts just to support the cab. And to be honest, that was a bit of a pain, didn't look good, and took a considerable time to do. In this clip, I'm cleaning off the sharp edges of the final piece of steel. And after a final check of all the parts, there was just one sharp edge left to remove. This may be a bit boring to some people, but it's well worth mentioning. I mentioned in a previous episode that I recently bought this excellent battery-powered detail sander, and I'm using this to roughen up the surface of the pieces of steel. I'll be doing this again before I paint them. This is just to show you the principle. It's much quicker than using a piece of emery cloth, and at my age, anything that saves time is generally a good thing. Here are the 3 parts on the bench. They are not shiny and slippery, and the edges have been removed, and they're ready to be worked on. I didn't sand them to make them less slippery, I sanded them to give the paint that's going on there a very good key. What I'm showing here I don't really need to do. I'm removing the brass angle because I don't want to use this, and in exactly the same way as on the front part, it's held together using countersunk, slot-headed machine screws. Note the great workmanship in drilling the holes to mount the reversing lever. I'm not going to throw away these pieces of steel, I'm sure they'll come in useful for something. Look at this bodge on one of the side plates. Obviously the holes were drilled in the wrong place and then filled in using soft solder. On the panel at this side I managed to remove the slot-headed countersunk bolts very easily, but the countersinks on the other plate weren't countersunk deep enough, so the builder obviously thought, I know, I will file off the heads flush with the plate. I think this was done by the second builder because whoever machined the wheels and the cylinders and made the frames was very good. I have a wood chisel that I use for chiselling bolts. Here it is. I just hit it with a hammer and the bolts drop off. It does actually damage the chisel, which is not a big problem. I just resharpen it after I've done the job, ready for the next one. And to prove that, here is the chisel, still warm after the resharpening job, all ready for the next time I use it. And that is it for this episode. I'd just like to say, as I always do, stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.